The density of pure gold is 42.5 pounds per liter. You find a 1.0 cubic foot ore of pure gold. How many pounds is this ore? So let's do some dimensional analysis. In the problem, we're given 1.0 cubic feet of gold. So this means that the unit of feet is cubed, and this, of course, is a volume. The other item that's given to us is the density. We are told that 1 liter of gold is 42.5 pounds. So this is our density. And the question is, if we found this 1.0 cubic foot chunk of gold, what would be the weight in pounds? So we'll have to convert the volume to liters. And once we have that unit of liters, we can use the density as our conversion factor to convert the liters into pounds. In some conversion tables, you do have the foot cubed into liter conversion, but let's assume that you don't. And so what I'll do here is I'll draw myself a map. This, again, just to help me organize myself. So from cubic feet, what I can do is convert this into inches cubed. And so we can do centimeters cubed. From centimeters cubed, we can convert to milliliter. And of course, from milliliter, we can convert to liters. And so for my students, I usually call this my map, my road map. So let's go ahead and set up our ratios. So in my first ratio, I'll convert feet to inches. Now, something interesting happens here. You have to be careful with these volumes in terms of cubic length. This ratio here, we know that there are 12 inches in a foot. However, this is foot cubed. And so we'll have to cube that unit. And when we cube the unit, we also have to cube the value or the ratio. So just be careful with that in your calculations. From inches, we can go to centimeters. Again, this is a length conversion. Most tables will have this type of conversion. 1 inch is 2.54 centimeters. Again, this is a length conversion, but we're looking at volume here, so we'll have to cube the units, but don't forget to also cube your values here. So now we're in units of centimeter cubed. I'll go ahead and convert this to milliliter. And this is the actual definition of a milliliter. 1 milliliter is 1 centimeter cubed. So this ratio is just simply 1 to 1. And finally, we'll convert milliliter to liter. And we know that there are 1,000 milliliters in a liter. So let's pause there for a moment and let's check those units. One thing I always tell my students, check those units. If we check the units and the units that we want to cancel do cancel, that at least tells us that we're setting up our ratios correctly. And if you take a close look here, you notice that all these ratios show that these units are canceling. The foot cube cancel, the inch cube cancel, centimeter cubes cancel, and the milliliters cancel. So we're left with units of liters, which is exactly what I want. I'll go ahead and keep going here. Here's my last ratio. So now I have the unit of liters. I'll convert this to pounds and cancel liters. So this mass to volume relationship, this is the density that's given to me at the beginning of the problem. And for my students, this is exactly what I want to see. All these units cancel. The only unit that doesn't cancel is the unit that I want, which is my pounds. So we'll plug this into the calculator. Just be mindful of the cubes. This 12 is cubed. The 2.54, that's cubed. And the answer we get here to two significant figures, 1.2 times 10 raised to the 3 pounds. I also want to show you this ratio right here. 1 foot cubed, and we'll convert this to liters and cancel the foot cubed. And in the ratios that I give my students on this table, you see the volume ratios. At least in this table, I do have the foot cube to liter conversion, so I can actually just plug this in. So if you have this table, of course, this would be the simplest way to get there. So 1 foot cubed is 28.32 liters. And then, of course, that last step here stays the same, 42.5 pound for every 1 liter. And the answer I get there, again, at least to 2 significant figures. This is 1.2 times 10 raised to the 3 pounds. So we get the same answer, which is expected. So 2 examples on how to convert the foot cubed into liters, and then using the density to convert liters into pounds.